You probably have one on your kitchen counter right now, a perfect yellow curve. But the banana you're eating is a genetic clone, a biological miracle currently being hunted by an invisible killer. 7,000 years ago in the Cook Valley of Papua New Guinea, the original wild ancestors, Musa acuminata and Musa balbisiana, were nearly inedible. They were small, tough, and packed with hard pea-sized seeds that could break your teeth. Domestication relied on a rare mutation called parthenocarpy, a biological glitch where the fruit develops without fertilization. In these rare plants, the seeds shrank into nothing, leaving behind a fleshy, seedless core. These mutants were sterile and could not reproduce on their own. To keep them alive, humans began taking suckers from the base of the plant and replanting them in the soil. This manual replanting created a 7,000-year-old unbroken chain of cloning. Every banana plant in that lineage became a perfect genetic copy of its parent. These clones traveled with human migrants to sub-Saharan Africa and eventually to the Middle East. The modern name actually comes from the Arabic word banan, meaning finger. In the early 1800s, Americans treated the rare arrivals of the fruit as an exotic luxury. Bananas were often sold individually wrapped in tinfoil, a status symbol for the Victorian era. At the 1876 Centennial Exposition in Philadelphia, visitors paid 10 cents, a significant sum at the time, just to taste a single slice. They were told to eat it with a knife and fork, as if it were a fine steak. This shift in perception transformed a regional calorie staple into a global commodity, setting the stage for industrial-scale monocultures. In the late 19th century, entrepreneur Minor Keith was building a railroad in Costa Rica. He planted bananas along the tracks to feed his workers, and soon discovered the fruit was more profitable than the railroad itself. Keith's United Fruit Company eventually controlled the governments of entire nations. In 1911, a businessman named Sam Zemere hired mercenaries to overthrow the government of Honduras to secure tax breaks for his plantations. During this era, the world ate the Gros Michel. Known as Big Mike, it was larger and creamier than today's bananas, with a thick skin that allowed it to be shipped in massive bunches without bruising. The Gros Michel had a fatal vulnerability. Every clone shared the exact same immune system. In the 1920s, a soil-borne fungus called Panama disease swept through the plantations. It entered the roots, choking the water supply. With zero genetic diversity, there was zero resistance. By the 1950s, the commercial Gros Michel was functionally extinct. The multi-billion-dollar industry was on the verge of total collapse. Scientists found a replacement in a greenhouse on the estate of the Duke of Devonshire. This variety, the Cavendish, was smaller and more fragile than the Gros Michel, but it was immune to the current strain of Panama disease. To handle the delicate Cavendish, the entire global supply chain was redesigned. The industry invested in refrigerated steamships and began packing the fruit in cardboard boxes instead of hanging bunches. Because the Cavendish is also seedless and sterile, new plants are grown by cutting pieces of the rhizome from existing stalks. This means 99% of all exported bananas today are genetically identical clones. Rather than diversifying the crop after the loss of the Gros Michel, the industry simply swapped one global monoculture for another. History is now repeating itself. A new strain of the fungus, tropical race 4, has emerged to kill the Cavendish. It can live in the soil for 40 years, waiting for a banana root to touch it. The fungus started in Asia, moved to Australia, and was officially detected in Colombia in 2019. There is no known chemical cure. In Australia, researchers are using CRISPR gene editing to keep the fruit on shelves. They have developed the QCAV4, a genetically modified Cavendish spliced with a gene from a resistant wild banana. With no backup variety waiting in a greenhouse this time, we are literally rewriting the banana's DNA to save it from extinction. This fruit is a concentrated package of the Earth's minerals. It contains enough potassium-40 that eating one exposes you to 0.1 microsieverts of radiation, a metric physicists call the banana equivalent dose. For millions of people in the tropics, this isn't a snack. It provides 25% of their daily caloric intake. Its loss would be a humanitarian catastrophe. We took a wild species and stripped it of its natural diversity to create a uniform, convenient product. We took a wild, seedy jungle plant and forced it to become a uniform, seedless clone for our own convenience. But in doing so, we stripped it of the one thing every species needs to survive: diversity. The next time you walk through the produce aisle and see those yellow curves for 60 cents a pound, remember the 7,000-year journey they took to get there. The water is doing the work, the scientists are doing the editing, but the clock is ticking. Don't forget to hit the bell to stay updated.